This video involves converting improper fractions and mixed numbers. Make sure that you have some paper and pencil ready because there are going to be some strategies in this video to help you solve many problems that you will encounter involving mixed numbers as well as improper fractions. Okay, given what we know about improper fractions and mixed numbers, that they are equal. So an improper fraction being a fraction with a value greater than or equal to 1, where the numerator is greater than the denominator, and a mixed number being a whole number as well as a fraction describing a value that is greater than 1. We know that they can be equal by showing two different possibilities. First, I'm going to draw a picture of what this tells me. Okay, what it tells me is there's three parts of a group of things that is broken into two parts. Okay, so I know that this is equal to or greater than 1. So I'm just going to draw 2 to start. And I know that each of these wholes, okay, because they're whole parts, they're going to be broken into two different parts, and that's what my denominator says. And I need to eventually shade 3 of those 2 parts, okay? And I'm going to eventually bleed into the other areas because, once again, an improper fraction describes a value that is greater than or equal to 1. That's why I drew 2. Okay, so I'm just going to shade 3 of these because each of these wholes is 1/2 and then a second half. So this describes 2 halves, this describes 2 halves, but let's make sure that when we do this, we're only shading what we need. So we have 3 halves, and we need to shade. So this is 1/2, 2 halves, or 1 whole, and then another half to make it 3 halves, 1, 2, and 3. Okay, and what this tells me, if I count this in terms of a mixed number, I would have 1 whole and 1/2 of another, meaning that 3 halves equals 1 and 1/2. Another model for showing the equivalence between improper fractions and mixed numbers is using the improper fraction to show division. As we know, fractions themselves show division as the numerator divided by the denominator. So in this example, we're going to show 3 divided by 2. So I'm just going to set it up right here. 3 divided by 2. Okay, and let's just go through the motions of this division. It's 2 goes into 3 once. 1 times 2 is 2. When I subtract 3 and 2, I get 1. Okay, and I'm going to stop right here. Normally I would say this is 1, remainder 1, but what that means is that I have 1 and something left over. Okay, and that's sort of like the way I like to describe mixed numbers. It's 1 and something else, or the whole number and a little something extra. Okay, so this, I have an answer, and I have a little something extra of a remainder. But I'm not going to use it as a remainder because I can use that as a fraction. So what I'm going to do is I'm going to say this is 1 and 1/2. And that's how it's going to work all the time. But once again, it's the top 1 and 1/2. Once again, that's the quotient, the remainder, and the divisor. And notice, it's the same as this. So the 3 divided by the 2, which is the same as the improper fraction setup, we would once again get 1 and 1/2, showing the equivalence between improper fractions and mixed numbers. Using different numbers to show the same model, I'm going to demonstrate again how we would draw a picture and then also divide the improper fraction to find the mixed number. So in this model, I need to set up 13/5. So what that shows is I need to demonstrate a few wholes here. I'm going to start with 3. That might be what I need, but I'm going to break these into 5 pieces. So 1, 2, 3, 4. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and of those, what I need to do is I need to shade in 13 of those fifths. Once again, if this was a whole, it would be 5/5, each of these being 1/5. So 1/5, 2/5, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm going to shade from here to the left, showing 13/5. And then I should be able to see, after I've finished shading in all of these fifths, matching it up to my mixed number model. I see 1 whole shaded, I see a second whole shaded, that would be my whole number. Okay, And then how much of this is shaded? 1, 2, and 3 out of a total of 5 spots. So we get 2 3/5 equals the same as 13/5 given the visual model. And once again, using the division that the improper fraction sets up, I am going to divide 13 by 5. Let me set up my dashes above the place values for each of these numbers. And I know 5 goes into 1 0 times, so I'm going to extend to the 13. 5 goes into 13 twice. 2 times 5 is 10. Subtract these numbers and I get 3. Okay. And notice here, the same thing happens. We circle the top, 2 and 3/5, because we know it's 2 and something left over with the remainder. So the quotient and the remainder over the divisor, which equals 2 3/5. And I know what you're thinking. What if we are not given the improper fraction? Both of those models went from improper to mixed number. What if we're only given the mixed number? What if we need to solve that? Well, we could also draw a picture, but I want to visually think about what the picture means. Okay, the previous model that we had always started with the denominator. So we're going to start with the denominator here. And what I want to do is I want to describe those wholes in terms of 3. So 3 of 3 is 9. This is my chunked information. That number is just going to stay in my head. Once again, what we're drawing here is 3 holes, and each of those 3 holes has 3 pieces in it, because that's what this model shows. Okay, and that's all 3 of these in each of these 3 is covered. So that means it's showing 9. 9 pieces are covered, but we can't forget about this one little part right here. So this is the remainder part. This is that little extra in our division model. Okay, so we need to shade that one more, and that means we need to add 1 to our 9, giving us 10. 10 what? Well, we always describe this in terms of our denominator, so it's 10/3. Okay, meaning the same as 3 1/3. Okay, and if you don't believe me, write 10/3 over here with an equal sign, that it equals the 3 1/3. Okay, and then let's divide 10 by 3. Okay, don't forget our dashes. 3 goes into 1 0 times. 3 goes into 10 3 times. 3 times 3 is 9. Subtract, we get 1. Remember, this is the remainder. So we're left with 3 1/3. 3 and a little extra. 3 1/3, meaning it's the same as this. Hopefully you found this video helpful when converting from improper fractions to mixed numbers, as well as from mixed numbers to improper fractions. Make sure we're using those strategies that were described in this video. If you feel like you need some more help, rewatch the video. If you want some guidance on other topics, there's more videos in this channel.